Hello guys, my name is Prince and this is Math Center. Subscribe to my YouTube channel for more videos. Post your comments and questions on my social media handles and I'll respond to it. We are beginning a new topic today, modular arithmetic. Here are the objectives that we look forward to achieving at the end of this topic. At the end of this topic, you should understand the concept of modular arithmetic. You should be able to add, subtract, and multiply numbers in a given modulus. You should be able to draw addition and multiplication tables for a given modulus. And finally, you should be able to solve questions involving modular arithmetic and binary operation. Let's learn more about modular arithmetic. Modular arithmetic is a system of arithmetic for integers where numbers wrap around after they reach a certain value called the modulus. What does this statement mean? To help us understand it, let's consider this simple circular surface that is numbered from 0 to 3. We want to move round this circular surface in a clockwise direction. We will begin at the 0 mark. So before we start moving, our arrow points to the 0 mark. We are moving in a clockwise direction. So we move from 0 to 1, from 1 to 2, from 2 to 3. Then from 3, we will move back to 0. We move again from 0 to 1, 1 to 2, 2 to 3. Then we move back to 0. From 0 to 1, 1 to 2, 2 to 3, and the process continues on and on. Now let's consider this set of numbers very carefully. If you look at it closely, we can see that something interesting is happening here. We move from 0 to 1, 1 to 2, 2 to 3. We know that if we continue in this manner, then we should move from 3 to 4. But look at something. When we get to the number 4, the numbers will wrap around or they will end, and then we begin the whole process all over again. So when we get to the number 4, the numbers wrap around or they end, then we begin counting from 0 all over again. So when we get to 4, we will have 0, then 1, 2, 3. When we get to 4 again, the numbers wrap around or they end, then we begin counting all over again. So when we get to 4, we write 0, then 1, 2, 3, and the process will continue on and on. This system of writing numbers is what is known as modular arithmetic, a system where numbers wrap around after they reach a certain value called the modulus. So we can see from here that after we reach the number 4, the numbers will wrap around or they will end. Then we begin the whole process all over again. The point is that modular arithmetic is a system for integers where numbers wrap around after they reach a certain value called the modulus. In this example, when we reach the number 4, the numbers will wrap around. So it means that in this case, the modulus is the number 4. So in our example here, the modulus is 4, or as is commonly said, these numbers are in mode 4. Let's consider another example. We have seen that these numbers are in mode 4. So we have 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3, and the order will continue on and on. Let's consider this example too. We have 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2, and the order will continue on and on. If you look at this one also very carefully, we can see that after we get to the number 3, the numbers will wrap around or they will end and the whole process begins all over again. So we have 0, 1, 2. But when we get to the number 3, we will end and begin all over again. So we have 0, 1, 2. When we get to 3, we have 0, 1, 2. When we get to 3, we have 0, 1, 2. So in this set of numbers, the modulus is 3 because when we get to the number 3, the numbers will wrap around or they will end and then we begin counting again. So the modulus is 3, or we say that these numbers are in mode 3. So the modulus here is 3. Let's consider another one. We have 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 0, 1, and the order will continue on and on. If you look at this one also very carefully, we can see that we move from 0 to 1, 1 to 2, 2 to 3, 3 to 4. But when we get to the number 5, the numbers will wrap around or they will end. Then we begin counting all over again. So in this set of numbers, the modulus is 5, or we say that these numbers are in mode 5. So modular arithmetic is very simple. It is a system for integers where the numbers will wrap around after they reach a certain value, and that value is called the modulus. In the first set, we can see that after we reach the number 4, the numbers will wrap around. So we say that these numbers are in mode 4, or the modulus is 4. In the second set, after we reach the number 3, the numbers will wrap around. So we say that these numbers are in mode 3, or the modulus is 3. And in the third set, the numbers wrap around after we reach 5. So the modulus is 5, or we say that these numbers are in mode 5. Let's consider another thing. If you look at these numbers very carefully, we can see that in mode 4, the set of numbers used are 0, 1, 2, 3. In mode 3, the set of numbers used are 0, 1, 2. In mode 5, the set of numbers used are 0, 1, 2, 3, 4. So if you follow in this same order, then it means that in mode 6, the set of numbers used will be 0, 1, 2, 3, 4, 5. In mode 7, the set of numbers will be from 0 to 6. In mode 8, the set of numbers will be from 0 to 7. So let's note that the set of numbers in mode 2 are 0 and 1. The set of numbers in mode 3 are 0, 1, 2. The set of numbers in mode 4 are 0, 1, 2, 3. The set of numbers in mode 5 are 0, 1, 2, 3, 4. And the order continues on and on. So in mode 6, the set of numbers will be 0, 1, 2, 3, 4, 5. In mode 7, the set of numbers will be from 0 to 6 and so on. So we can see that in each mode, we have a specific set of numbers that we can use. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to learn how to find the value of a number in a given modulus. Bye-bye. Welcome back. We are on the topic modular arithmetic. In the previous video, we learned the definition of modular arithmetic. We also learned how to find the set of numbers used in a given modulus. In this video, we are going to learn how to find the value of a number in a given modulus. Let's consider this number line. On this number line, we have the set of whole numbers from 0 to 10. In the previous video, we learned that in any given modulus, we have a set of values that are used. So for example, in mode 2, the set of values used are 0 and 1. In mode 3, the set of values used are 0, 1, and 2. In mode 4, the set of values used are 0, 1, 2, and 3. This means that the value of any number in mode 4 will be either 0, 1, 2, or 3, because the set of values in mode 4 are 0, 1, 2, and 3. So the value of any number in mode 4 will be either 0, 1, 2, or 3. Let's say that we want to find the value of 7 in mode 4. How are we going to do that? We are going to list the set of values in mode 4 alongside the set of whole numbers that we have on our number line. Then we pick the number that corresponds to 7. Now this is what I mean. We know that in mode 4, The set of values we use are 0, 1, 2, and 3. So we will list these values alongside the set of whole numbers that we have on our number line. This is the starting point, so we are going to start from here. The first number is 0, the second number in mode 4 is 1, the third number in mode 4 is 2, the fourth number in mode 4 is 3. We learned in the previous video that in mode 4, when we get to the number 4, the numbers will wrap around. That is, they will end and we will begin counting from 0. So when we get to 4, the numbers will end and we will begin counting from 0. So 4 will be 0. Then the next one will be 1. We have 2, 3. When we get to 4, the numbers will wrap around and we will begin counting all over again. So it means that after 3, you have 0, 1, and 2. So you can see that we have written the numbers in mode 4 alongside the set of whole numbers. So on this number line, the down part is the set of whole numbers and the top part is the numbers in mode 4. So the numbers we have here are in mode 4 and this is the set of whole numbers. We want to find the value of 7 in mode 4. The value of 7 in mode 4 is written as 7 mode 4. The value of 7 in mode 4 is written as 7 mode 4. As I said previously, to find the value of 7 in mode 4, we will list the set of numbers in mode 4 alongside the set of whole numbers. Then we will pick the value that corresponds to 7. On this number line, we can see that 7 corresponds to 3. So it means that the value of 7 in mode 4 is 3. The value of 7 in mode 4 is 3. We have seen that the value of 7 in mode 4 is written as 7 mode 4. So it means that 7 mode 4 is equal to 3. Here is another example. We want to find the value of 2 in mode 4. 2 in mode 4 is written as 2 mode 4. To find the value of 2 in mode 4, we are going to look for the number that corresponds to 2 in mode 4. From our number line, the number that corresponds to 2 in mode 4 is 2. So it means that the value of 2 in mode 4 is 2. We have seen that the value of 2 in mode 4 is written as 2 mode 4. So 2 mode 4 is equal to 2. Let's consider another example. We want to find the value of 4 in mode 4. The value of 4 in mode 4 is written as 4 mode 4. So for example, the value of 5 in mode 3 will be written as 5 mode 3. The value of 1 in mode 2 will be written as 1 mode 2. So the value of 4 in mode 4 is written as 4 mode 4. So anytime you write 4 mode 4, it means the value of 4 in mode 4. To find the value of 4 in mode 4, we look for the number that corresponds to 4 in mode 4. From our number line, the number that corresponds to 4 in mode 4 is 0. So it means that the value of 4 in mode 4 is 0. This means that 4 mode 4 is 0. So you can see that using this approach, we can find the value of any number in any given mode. So for example, if you want to find the value of 5 in mode 5, all you do is to list the set of numbers in mode 5 against this set of whole numbers. Then the one that corresponds to 5, that will give you the value of 5 in mode 5. Now let's look at something here. What if we want to find the value of 20 in mode 4? From our number line, if you want to find the value of 20 in mode 4, we will have to extend this number line to include 20. Then we list the set of values in mode 4 against it. The one that will correspond to 20 will give us the value of 20 in mode 4. That will be time consuming, but fortunately for us, we have a very simple method of doing it. We are going to consider that method in the next video. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to consider a very simple method of finding the value of a positive number in a given modulus. Bye-bye. Welcome back. We are on the topic modular arithmetic. In the previous video, we learned how to use the number line to find the value of a number in a given modulus. In this video, we are going to learn a very simple method of finding the value of a number in a given modulus. Finding the value of a positive number in a given modulus. We will learn how to find the value of a positive number in a given modulus under three conditions. The first one is when the number is less than the modulus. The value of x in mod y, which is written as x mod y, is x if x is less than y. The value of x in mod y, which is written as x mod y, is x if x is less than y. This means that x mod y is equal to x if x is less than y. So if the number x is less than the modulus y, then x mod y is equal to x. So for example, 2 mod 3 is equal to 2. 2 is less than 3, so 2 in mod 3 will give us 2. Here's another example. 5 mod 7 is equal to 5. The number 5 is less than the modulus 7, so 5 in mod 7, which is written as 5 mod 7, is equal to 5. Here's another example. 1 mod 2 is equal to 1. The number 1 is less than the modulus, which is 2, so 1 mod 2 is equal to 1. Another example is 15 mod 24 is equal to 15. The number 15 is less than the modulus, which is 24. So 15 in mod 24, which is written as 15 mod 24, will give us 15. So if the number x is less than the modulus y, then x mod y is equal to x. Let's consider the second condition. When the number is equal to the modulus. The value of x in mod x, which is written as x mod x, is 0. So x mod x is equal to 0. This means that when the number is equal to the modulus, then the value of the number in that modulus is 0. So the number x is the same as the modulus, which is x. So x mod x will give us 0. For example, 3 mod 3 is equal to 0. 5 mod 5 is equal to 0. 2 mod 2 is equal to 0. And 13 mod 13 is equal to 0. So if the number is equal to the modulus, then the value of that number in the modulus is 0. So 3 mod 3 is 0, 5 mod 5 is 0, 2 mod 2 is 0, and 13 mod 13 is 0. If the number is the same as the modulus, then the value of the number in that modulus is 0. The third condition is when the number is greater than the modulus. When the number is greater than the modulus. We have considered when the number is less than the modulus and when the number is equal to the modulus. We are now going to consider when the number is greater than the modulus. If x is greater than y, then the value of x in mod y, which is written as x mod y, is a. And a is the remainder when x is divided by y. This means that if x is greater than y, then x mod y is equal to a, where a is the remainder when x is divided by y. So for example, 5 mod 2 is equal to 1. We can see that 5, which is the number, is greater than the modulus, which is 2. So here, to find the value of 5 in mod 2, what you are going to do is that you will divide 5 by 2. 5 divided by 2 will give us 2 remainder 1. So the value of 5 in mode 2 is the remainder when you divide 5 by 2. When we divide 5 by 2, you get 2 and a remainder of 1. So 5 in mode 2 is equal to 1, because when we divide 5 by 2, we get a remainder of 1. Another example is 8 mode 4. 8 mode 4 is equal to 0. We have learnt that if the number is greater than the modulus, then the value of that number in the modulus is the remainder when we divide the number by the modulus. So here, to find the value of 8 in mode 4, we will divide 8 by 4. 8 divided by 4 will give us 2 remainder 0. The value of 8 mode 4 is the remainder when we divide 8 by 4. When we divide 8 by 4, we get a remainder of 0. So 8 mode 4 is equal to 0. The next example is 27 mode 5. 27, which is the number, is greater than 5. The value of 27 in mode 5 is the remainder when we divide 27 by 5. When we divide 27 by 5, we will get 5 remainder 2. So the remainder when we divide 27 by 5 is 2. It means that 27 mode 5 is 2. Another example is 10 mode 3. 10 is greater than 3. So the value of 10 in mode 3 is the remainder when we divide 10 by 3. When we divide 10 by 3, we will get 3 remainder 1. The value of 10 in mode 3 is the remainder when we divide 10 by 3. 10 divided by 3 will give us 3 remainder 1. So 10 mode 3 is equal to 1. So when the number is greater than the modulus, the value of the number in that modulus is the remainder when we divide the number by the modulus. Thank you for watching this video. Subscribe to this channel for more videos. In this video, we have learned how to find the value of a positive whole number when the number is less than the modulus, when the number is equal to the modulus, and when the number is greater than the modulus. In the next video, we are going to learn how to find the value of a negative whole number in a given modulus. Bye-bye. Welcome back. We are still on the topic modular arithmetic. In the previous video, we learned how to find the value of a positive whole number in a given modulus. In this video, we are going to learn how to find the value of a negative whole number in a given modulus. Finding the value of a negative whole number in a given modulus. The value of a negative number in a given modulus is obtained by adding the modulus to the number until we get a positive number. The value of a negative number in a given modulus is obtained by adding the modulus to the number until we get a positive number. So for example, to find the value of negative 7 in mode 2, we will add the modulus, which is 2, to the number until we get a positive number. So to begin with, we will add 2 to the number, which is negative 7. So we have negative 7 plus 2, and that will give us negative 5. We will keep on adding 2 to the number until we get a positive number. When we added 2 to 7, we had negative 5. Negative 5 is not a positive number, so you add 2 to it again. So you have negative 5 plus 2. Negative 5 plus 2 will give us negative 3. Negative 3 is not a positive number, so you add 2 to it again, and that will give us negative 3 plus 2. Negative 3 plus 2 will give us negative 1. Negative 1 is still not a positive number, so you add 2 to it again, and that will give us negative 1 plus 2. Negative 1 plus 2 is 1. The first positive number you will have is the value of that number in the modulus. So here, the first positive number we are having is 1. It means that the value of negative 7 in mode 2, which is written as negative 7 mode 2, is 1. So negative 7 mode 2 is equal to 1. So to find the value of a negative number in a given modulus, all you need to do is to keep on adding the modulus to the number until you get the first positive number. Here is another example. We want to find the value of negative 6 in mode 4. So we want to find negative 6 mode 4. We will add 4 to negative 6. We will have negative 6 plus 4, and that will give us negative 2. Negative 2 is not a positive number, so you will add the modulus to it again. We have negative 2 plus 4. Negative 2 plus 4 will give us 2. We now have a positive number. So it means that the value of negative 6 in mode 4 or negative 6 mode 4 is equal to 2. Let's consider another example. Negative 2 mode 3. We want to find the value of negative 2 in mode 3. We have seen that to find the value of a negative whole number in a given modulus, you add the modulus to the number until you get a positive number. So here we are going to add the modulus to negative 2. The modulus is 3, so you have negative 2 plus 3. Negative 2 plus 3 is giving us 1, so we have a positive number here. It means that the value of negative 2 in mode 3 or negative 2 mode 3 is equal to 1. So you can see that to find the value of a negative whole number in a modulus is very simple. You keep on adding the modulus to the number until you get a positive number. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to learn how to add, subtract, and multiply numbers in a given modulus. Bye-bye. Welcome back. We are on the topic modular arithmetic. In the previous video, we learned how to find the value of a negative whole number in a given modulus. In this video, we will learn how to add, subtract, and multiply numbers in a given modulus. Addition, subtraction, and multiplication of numbers in a given modulus. We will begin with addition. If we have a plus b mod y, it is equal to a plus b mod y. So for example, 7 plus 3 mod 4 is equal to 7 plus 3 into brackets mod 4. 7 plus 3 will give us 10. So 7 plus 3 mod 4 will give us 10 mod 4. We have learned how to find the value of a number in a given modulus. We learned that if the number is greater than the modulus, then the value of that number in the modulus is the remainder when we divide the number by the modulus. Here, 10 is greater than 4. So the value of 10 in mode 4 is the remainder when we divide 10 by 4. 10 divided by 4 will give us 2 remainder 2. So it means that when we divide 10 by 4, we will get a remainder of 2. So 10 mod 4 is equal to 2, which is the remainder. Let's consider another example. We have 2 plus 5 mod 9. So 2 plus 5 mod 9 will give us 2 plus 5 into brackets mod 9. 2 plus 5 is 7. So you have 7 mod 9. We have learned that if the number is less than the modulus, then the value of the number in the modulus is the same as the number. Here, 7 is less than 9. So it means that the value of 7 in mod 9 is equal to 7. Let's consider another example. We have 4 plus 4 mod 8. This will be equal to 4 plus 4 into brackets, then mod 8. 4 plus 4 will give us 8. So you have 8 mod 8. We have learned that if the number is the same as the modulus, then the value of the number in the modulus is 0. 8 is equal to 8, so 8 mod 8 will give us 0. Let's consider another example. We have minus 7 plus 15 mod 3. This will give us minus 7 plus 15 into brackets mod 3. Minus 7 plus 15 will give us 8. So you have 8 mod 3. 8 is greater than 3. So the value of 8 in mod 3 is the remainder when we divide 8 by 3. When you divide 8 by 3, we will get 2 remainder 2. So the value of 8 in mod 3 or 8 mod 3 is equal to the remainder, which is 2. So this is how to add numbers in a given modulus. Let's learn how to subtract numbers in a given modulus. Subtraction. A minus b mod y is equal to a minus b into brackets, then mod y. So for example, 8 minus 2 mod 3 will be equal to 8 minus 2 into bracket mod 3. 8 minus 2 will give us 6. So you have 6 mod 3. We have learned how to find the value of a number in a given modulus. We learned that if the number is greater than the modulus, then the value of the number in the modulus is the remainder when we divide the number by the modulus. So here the value of 6 in mod 3 is the remainder that we will get when we divide 6 by 3. 6 divided by 3 will give us 2 remainder 0. So it means that the value of 6 in mod 3 is equal to 0, because when we divide 6 by 3, we get a remainder of 0. Let's consider another example. We have 2 minus 5 mod 9. This will be equal to 2 minus 5 into brackets, then mod 9. 2 minus 5 will give us minus 3. So you have minus 3 mod 9. We have a negative number. We learnt in the previous video that to find the value of a negative number in a given modulus, you add the modulus to the number until you get a positive number. So here, to find the value of negative 3 in mod 9, you add 9 to negative 3. Negative 3 plus 9 will give us 6. 6 is a positive number, so the value of negative 3 in mod 9 is 6. Let's consider another example. 3 minus 1 mod 8. This will be equal to 3 minus 1 into brackets mod 8. 3 minus 1 will give us 2. So you have 2 mod 8. 2 is less than 8. So the value of 2 in mod 8 or 2 mod 8 is equal to 2. If the number is less than the modulus, then the value of the number in the modulus is equal to the number itself. So 2 in mod 8 is equal to 2. We have learned how to add and subtract numbers in a given modulus. Now let's learn how to multiply numbers in a given modulus. Multiplication. A times b mod y is equal to a times b into brackets mod y. So for example, 2 times 2 mod 6 will be equal to 2 times 2 into brackets mod 6. 2 times 2 will give us 4. So we have 4 mod 6. We have seen that 4 mod 6 is equal to 4, since 4 is less than 6. 2 times 5 mod 9 is equal to 2 times 5 into brackets mod 9. 2 times 5 will give us 10. So we have 10 mod 9. 10 is greater than 9. So the value of 10 in mod 9 is the remainder when we divide 10 by 9. 10 divided by 9 will give us 1 remainder 1. So 10 mod 9 is equal to 1. 3 times 0 mod 5 will be equal to 3 times 0 into brackets mod 5. 3 times 0 is 0, so you have 0 mod 5. 0 is less than 5, so 0 in mod 5 or 0 mod 5 is equal to 0. Finally, 1 times 1 mod 3 will be equal to 1 times 1 into brackets mod 3. 1 times 1 is 1, so you have 1 mod 3. 1 is less than 3, so the value of 1 in mod 3 is equal to 1. So you can see that addition, subtraction, and multiplication of numbers in a given modulus is very simple. You add, subtract, or multiply the numbers, then you find the value of that number in the given modulus. Thank you for watching this video. Subscribe to this channel for more videos. Now, we know how to add and multiply numbers in a given modulus. In the next video, we are going to learn how to draw addition and multiplication tables for a set of numbers in a given modulus. Bye-bye. Welcome back. We are on the topic modular arithmetic. In the previous video, we learned how to add, subtract, and multiply numbers in a given modulus. In this video, we are going to learn how to draw a table for an operation in a given modulus. Tables in modular arithmetic. To draw a table for an operation in a given modulus, the first thing you have to do is to define the set of values in that modulus. We have learned that in every modulus, there are a set of values that are used. So for example, in mode 2, the set of values used are 0 and 1. The set of values used in mode 3 are 0, 1, 2. In mode 4, the values are 0, 1, 2, 3. In mode 5, the values are 0, 1, 2, 3, 4. So to draw a table for an operation in a given modulus, the first thing you do is that you define the set of values in that modulus. So if you want to draw an addition table for mode 4, you will first have to define the set of values in mode 4. They are 0, 1, 2, and 3. If you want to draw a table in mode 3, the set of values are 0, 1, and 2. So you define the set of values in that modulus. After you have defined the set of values, you will use it to draw the table. So you draw the table using the set defined. For example, if you want to draw an addition table for mode 5, the first thing we have to do is to define the set of values in mode 5. The set of values used in mode 5 are 0, 1, 2, 3, 4. After we have defined the set of values, we use it to draw the table. We have 5 values here. So you draw a table with 6 columns and 6 rows. So in this table, the number of columns are 1, 2, 3, 4, 5, 6. And the number of rows are 1, 2, 3, 4, 5, 6. In the first cell, you will write the sign of the operation you are going to perform. We want to draw an addition table, so the operation is addition. So in the first cell of the table, you write the addition sign. So you write the addition sign, then we draw a circle around it. You then list the set of numbers in the first row and the first column, just as we have here. After you have drawn the table like this, you fill it out completely by performing the operation in the given modulus. So here we are going to fill this table by adding the numbers in mode 5. So we have our table here and we are going to fill it out by adding the numbers in mode 5. The first one will be 0 plus 0. 0 plus 0 is 0. Then you find the value of 0 in mode 5. 0 in mode 5 or 0 mode 5 is equal to 0. So it means that here will be 0. We have 0 plus 1. 0 plus 1 is 1. 1 mode 5 is 1. 0 plus 2. 0 plus 2 is 2. 2 mode 5 is 2. 0 plus 3. 0 plus 3 is 3. 3 mode 5 is 3. 0 plus 4 is 4. 4 mode 5 is 4. After you have completed the first rule, you come to the second rule. You will have 1 plus 0. 1 plus 0 is 1. 1 in mode 5 is 1. 1 plus 1 is 2. 2 in mode 5 is 2. 1 plus 2 is 3. 3 in mode 5 is 3. 1 plus 3 is 4. 4 in mode 5 is 4. 1 plus 4 is 5. 5 in mode 5 is 0. 2 plus 0 is 2. 2 in mode 5 is 2. 2 plus 1 is 3. 3 in mode 5 is 3. 2 plus 2 is 4. 4 in mode 5 is 4. 2 plus 3 is 5. 5 in mode 5 is 0. 2 plus 4 is 6. 6 in mode 5 is 1 because you divide 6 by 1 and you have 1 remainder 1. So you write the remainder. 2 plus 4 is 6 and 6 in mode 5 is 1. Let's move on to the next rule. You have 3 plus 0, which is 3. 3 in mode 5 is 3. 3 plus 1 is 4. 4 in mode 5 is 4. 3 plus 2 is 5. 5 in mode 5 is 0. 3 plus 3 is 6. 6 in mode 5 is 1. 3 plus 4 is 7. 7 in mode 5 is 2. The number is bigger than the modulus, so you divide 7 by 5 and that will give us 1 remainder 2. You write the remainder. So 3 plus 4 is 7 and 7 in mode 5 is 2. Let's move on to the last rule. 4 plus 0 is 4. 4 in mode 5 is 4. 4 plus 1 is 5. 5 in mode 5 is 0. 4 plus 2 is 6. 6 in mode 5 is 1. 4 plus 3 is 7. 7 in mode 5 is 2. And finally, 4 plus 4 is 8. 8 in mode 5 is 3. So we have now completed our addition table for mode 5. You can see that it's very simple. To draw a table for an operation in a given modulus, the first thing you have to do is to define the set of values in that modulus. After that, you use the set of values to draw the table. Then you fill out the table by performing the operation in the given modulus. So if the operation is addition, you add the numbers in the modulus. If the operation is multiplication, you multiply the numbers in the modulus. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on drawing a table for an operation in a given modulus. Bye-bye. Welcome back. We are on the topic modular arithmetic. In the previous video, we learned how to draw a table for an operation in a given modulus. In this video, we are going to solve a question on drawing tables for an operation in a given modulus. The question for this video is, draw a multiplication table for mode 6. We learned in the previous video that when you are asked to draw a table for an operation in a given modulus, the first thing you have to do is to define the set of values in that modulus. Here, we are being asked to draw a multiplication table for mode 6. So the first thing you do is to define the set of values used in mode 6. The set of values used in mode 6 are 0, 1, 2, 3, 4, 5. After you have defined the set of values, the next thing we have to do is to use this set of values to draw the table. We have 6 values in total, so we are going to draw a table with 7 columns and 7 rows. In the first cell of the table, you write the sign of the operation we are going to perform. We are going to draw a multiplication table, so the operation is multiplication. In the first cell of the table, you write the multiplication sign, then you draw a circle around it. Then you list the set of values in the first row and the first column, just as we have in this table. After you have drawn the table like this, you fill it out by performing the operation in the modulus. The operation is multiplication, and the modulus is 6. So we are going to multiply these numbers in mode 6. The first one is 0 times 0. 0 times 0 is 0. 0 in mode 6 is 0. So we have 0 here. 0 times 1 is 0. 0 in mode 6 is 0. 0 times 2 is 0. 0 in mode 6 is 0. 0 times 3 is 0. 0 in mode 6 is 0. 0 times 4 is 0. 0 in mode 6 is 0. And 0 times 5 is 0. 0 in mode 6 is 0. So in the first rule, all the numbers are 0. Let's move on to the next rule. 1 times 0 is 0. 0 in mode 6 is 0. 1 times 1 is 1. 1 in mode 6 is 1. 1 times 2 is 2. 2 in mode 6 is 2. 1 times 3 is 3. 3 in mode 6 is 3. 1 times 4 is 4. 4 in mode 6 is 4. 1 times 5 is 5. 5 in mode 6 is 5. Let's move on to the next rule. 2 times 0 is 0. 0 in mode 6 is 0. 2 times 1 is 2. 2 in mode 6 is 2. 2 times 2 is 4. 4 in mode 6 is 4. 2 times 3 is 6. 6 in mode 6 is 0. 2 times 4 is 8. 8 in mode 6 is 2. 2 times 5 is 10. 10 mode 6 is 4. Let's move on to the next rule. We have 3 times 0. 3 times 0 is 0. 0 mode 6 is 0. 3 times 1 is 3. 3 mode 6 is 3. 3 times 2 is 6. 6 mode 6 is 0. 3 times 3 is 9. 9 mode 6 is 3. 3 times 4 is 12. 12 mode 6 is 0 because 12 divided by 6 will give us 2 remainder 0. So you write the remainder. So 12 mode 6 is 0. 3 times 5 is 15. 15 mode 6 is 3. You divide 15 by 6, you have 2 remainder 3. So 15 mode 6 is 3. Let's move on to the next rule. 4 times 0 is 0. 0 mode 6 is 6. 4 times 1 is 4. 4 mode 6 is 4. 4 times 2 is 8. 8 mode 6 is 2. 4 times 3 is 12. 12 mode 6 is 0. 4 times 4 is 16. 16 mode 6 is 4. 4 times 5 is 20. 20 mode 6 is 2 because 20 divided by 6 will give us 3 remainder 2. Let's move on to the last rule. We have 5 times 0. 5 times 0 is 0. 0 mode 6 is 6. 5 times 1 is 5. 5 mode 6 is 5. 5 times 2 is 10. 10 mode 6 is 4. 5 times 3 is 15. 15 mode 6 is 3. 5 times 4 is 20. 20 mode 6 is 2. And finally, 5 times 5 is 25. 25 mode 6 is 1 because 25 divided by 6 will give us 4 remainder 1. I'm going to show you a very simple trick that you can use to find the value when the number is bigger than the modulus. So for example, when you have 25 mode 6, we can see that 25, which is the number, is bigger than 6, which is the modulus. I'm going to show you a trick that you can use. You subtract the modulus from the number and you keep on subtracting until you get a number that is less than the modulus. This is what I mean. You want to find 25 in mode 6. You search on your calculator. Subtract 6 from 25. So you have 25 minus 6. This will give us 19. 19 is bigger than the modulus, which is 6. So you subtract 6 from 19 again. So 19 minus 6. And that will give us 13. 13 is still bigger than the modulus, which is 6. So you subtract 6 again. 13 minus 6 will give us 7. 7 is still bigger than the modulus, which is 6. So you subtract 6 again and you have 1. Now 1 is less than the modulus, which is 6. So it means that 25 mode 6 is 1. Let's try for another example. Let's say 20 mode 6. So we are going to subtract 6 from 20 until we get a number that is less than 6. So you have 20 minus 6. 20 minus 6 will give us 14. 14 is not less than 6. So you subtract 6 from 14. 14 minus 6 will give us 8. 8 is still not less than 6. So you subtract 6 from it again. 8 minus 6, as we all know, will give us 2. So we can see that 20 mod 6 will give us 2. Let's try for another example. Let's say 15 mod 6. 15 mod 6. So you subtract 6 from 15 until you get a number that is less than 6. You have 15 minus 6, and that will give us 9. 9 is not less than 6, so you subtract 6 from it again. 9 minus 6, as you all know, you have 3. So it means that 15 mod 6 will give us 3. Let's try for 10 mod 6. 10 is bigger than the modulus. 10 is the number and 6 is the modulus. And you can see that 10 is bigger than 6. So to find 10 mod 6, if you want to use this trick, all you have to do is to subtract 6 from 10. 10 minus 6 will give us 4. 4 is less than 6, so it means that 10 mod 6 is 4. So when the number is bigger than the modulus, you can use this simple trick to find the value of that number in the modulus. You subtract the modulus from the number until you get a value that is smaller than the modulus. This trick can be very helpful when you are drawing addition and multiplication tables in modular arithmetic. Let's go back to our question. So we have now completed the multiplication table for mod 6. Thank you for watching this video. Subscribe to this channel for more videos. In the two examples that we have considered so far, that is the example in the previous video and the one in this video, we were asked to draw an addition table or multiplication table for a particular modulus. So we defined a set of values in that modulus and we used it to draw the table. Sometimes the set of values that you are going to use to draw the table will be defined for you. In the next video, we are going to solve a question on drawing a table for an operation in a given modulus when the set of values have been defined for you. Bye-bye. Welcome back. We are on the topic modular arithmetic. In the previous video, we solved a question on drawing a table for an operation in a given modulus. In this video, we are going to solve a question on drawing a table for an operation in a given modulus when the set of values have been defined for you. The question for this video is, draw a multiplication table for mod 7 on the set 2, 3, 5, 6. So in this question, the set of values that we are going to use in the table have been defined for us. This is quite different from the questions that we have solved in the previous videos. In those questions, we were asked to draw a multiplication or addition table for a particular modulus. So we list the set of values used in that modulus and then we use that set to draw the table. So for example, if the question had asked us to draw a multiplication table for mod 7, the first thing we would do is that we would define the set of values used in mod 7. The set of values used in mod 7 are 0, 1, 2, 3, 4, 5, 6. Then we will use this set of values to draw the table. After that, we will multiply the numbers in mod 7. This time, the question is asking us to draw a table for mod 7 on the set 2, 3, 5, 6. So the set of numbers that we are supposed to use in the table have been given to us. This means that when you are asked to draw a table for an operation in a given modulus and you are given a set of values in the question, you have to use that set of values to draw the table. So for this question, we are going to use the values in this set to draw the table. We have 4 values in this set, 2, 3, 5, 6. So we are going to draw a table with 5 columns and 5 rows. We are going to draw a multiplication table for mod 7. So the operation is multiplication. You write the multiplication sign in the first cell and then you draw a circle around it. After that, you list the numbers in the first row and the first column. So we have 2, 3, 5, 6. 2, 3, 5, 6. We are going to multiply these numbers in mode 7. So we begin with the first one. 2 times 2. 2 times 2 is 4. 4 in mode 7 is 4. 2 times 3 is 6. 6 in mode 7 is 6. 2 times 5 is 10. 10 in mode 7 is 3. In the previous video, I showed you a simple trick you can use to find the value when the number is bigger than the modulus. I said that you just have to subtract the modulus from the number until you get a value that is smaller than the modulus. So here we will subtract 7 from 10. 10 minus 7 will give us 3. 3 is smaller than the modulus, which is 7. So it means that 10 mod 7 is 3. Let's move on. 2 times 6 is 12. 12 mod 7 is 5. So when you subtract 7 from 12, you are going to get 5. 5 is smaller than the modulus, so 12 mod 7 is 5. Let's move on to the next rule. 3 times 2 is 6. 6 mod 7 is 6. 3 times 3 is 9. 9 mod 7 is 2. So you subtract 7 from 9 and you get 2. And 2 is smaller than the modulus, so 9 mod 7 is 2. 3 times 5 is 15. 15 mod 7 is 1. 15 is bigger than the modulus, which is 7. So you can use the trick that I showed you in the previous video to find 15 mod 7. You subtract 7 from 15. 15 minus 7 will give us 8. 8 is still bigger than the modulus, which is 7. So you subtract 7 from 8 again. 8 minus 7 will give us 1. So 15 mod 7 is 1. Let's move on. We have 3 times 6. 3 times 6 is 18. 18 mod 7 is equal to 4. So you subtract 7 from 18. 18 minus 7 will give us 11. 11 is still not smaller than the modulus, so you subtract 7 from 11 again. So 11 minus 7 will give us 4. It means that 18 mod 7 is 4. Let's move on to the next rule. 5 times 2 will give us 10. 10 mod 7 is 3. You subtract 7 from 10, you get 3. 5 times 3 will give us 15. 15 mod 7 is 1. You subtract 7 from 15, you get 8. Then you subtract 7 from 8, you get 1. So you keep on subtracting until you get a value that is smaller than the modulus. Let's move on. 5 times 5 is 25. 25 mod 7 is 4. You subtract 7 from 25 and you get 18. Then you subtract 7 from 18, you get 11. You subtract 7 from 11 and you get 4. So you keep on subtracting until you get a number that is smaller than the modulus. 25 mod 7 will give us 4. 5 times 6 will give us 30. 30 mod 7 is 2. So once again, you subtract 7 from 30. So we have 30 minus 7, and that will give us 23. You subtract 7 from 23, that will give us 16. You subtract 7 from 16, you have 9. Then you subtract 7 from 9 and you have 2. So it means that 30 mod 7 is 2. Let's move on to the last rule. 6 times 2 will give us 12. 12 mod 7 is 5. You subtract 7 from 12 and you get 5. 5 is smaller than the modulus, so 12 mod 7 is 5. 6 times 3 is 18. You subtract 7 from 18 and you get 11. You subtract 7 from 11, you get 4. So 18 mod 7 is 4. 6 times 5 is 30. 30 mod 7 is 2. And finally, 6 times 6 is 36. 36 mod 7 is 1. You subtract 7 from 36, so you have 36 minus 7, and that will give us 29. You subtract 7 from 29, and that will give us 22. You subtract 7 from 22, that will give us 15. You subtract 7 from 15, you have 8. Then you subtract 7 from 8, and you have 1. So 36 mod 7 is 1. We have now completed our multiplication table for mode 7 on the set 2, 3, 5, 6. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on drawing a table for an operation in a given modulus when the set of values have been defined for you. Bye-bye. Welcome back. We are still on the topic modular arithmetic. In the previous video, we solved a question on drawing a table for an operation in a given modulus where the set of values have been defined for you. In this video, we are going to solve another question. The question for this video is, draw an addition table for mode 8 on the set 0, 1, 3, 5, 7. We learned in the previous video that when you are asked to draw a table for an operation in a given modulus, and the question defines the set of values for you, you are supposed to use that set of values to draw the table. Here, the question is asking us to draw an addition table for mode 8 on the set 0, 1, 3, 5, 7. So we are going to use the numbers 0, 1, 3, 5, 7 to draw the table. We have 5 numbers here, so we are going to draw a table with 6 columns and 6 rows. In the first cell, you indicate the sign of the operation you are going to perform. We are going to draw an addition table, so you write the addition sign in the first cell and then you draw a circle around it. After that, you list the set of numbers in the first row and the first column. So we have 0, 1, 3, 5, 7 and 0, 1, 3, 5, 7. We are drawing an addition table for mode 8. So we will add the numbers in mode 8. The first one is 0 plus 0. 0 plus 0 is 0. 0 in mode 8 is 0. 0 plus 1 is 1. 1 in mode 8 is 1. 0 plus 3 is 3. 3 in mode 8 is 3. 0 plus 5 is 5. 5 in mode 8 is 5. 0 plus 7 is 7. 7 in mode 8 is 7. We move on to the next rule. 1 plus 0 is 1. 1 in mode 8 is 1. 1 plus 1 is 2. 2 in mode 8 is 2. 1 plus 3 is 4. 4 in mode 8 is 4. 1 plus 5 is 6. 6 in mode 8 is 6. 1 plus 7 is 8. 8 in mode 8 is 0. Let's move on to the next rule. 3 plus 0 is 3. 3 in mode 8 is 3. 3 plus 1 is 4. 4 in mode 8 is 4. 3 plus 3 is 6. 6 in mode 8 is 6. 3 plus 5 is 8. 8 in mode 8 is 0. 3 plus 7 is 10. 10 in mode 8 is 2. The number, which is 10, is greater than the modulus 8. So you divide 10 by 8 and that will give us 1 remainder 2. So 10 mode 8 is equal to the remainder, which is 2. You can also use the trick that I showed you in the previous video. You subtract 8 from 10. 10 minus 8 will give us 2. 2 is less than the modulus, so 10 mode 8 is equal to 2. Let's move on to the next rule. 5 plus 0 is 5. 5 mode 8 is 5. 5 plus 1 is 6. 6 mode 8 is 6. 5 plus 3 is 8. 8 mode 8 is 0. 5 plus 5 is 10. 10 mode 8 is 2. 5 plus 7 is 12. 12 mode 8 is 4. 12 is greater than the modulus, which is 8. So we divide 12 by 8 and you have 1 remainder 4. Or you can use the trick we learned in the previous video. You subtract 8 from 12 and that will give us 4. 4 is less than the modulus, which is 8. So 12 mode 8 is 4. Let's move on to the last rule. 7 plus 0 is 7. 7 mode 8 is 7. 7 plus 1 is 8. 8 mode 8 is 0. 7 plus 3 is 10. 10 mode 8 is 2. 7 plus 5 is 12. 12 mode 8 is 4. And finally, 7 plus 7 is 14. 14 mod 8 is 8. 14 is greater than the modulus 8. So you divide 14 by 8. 14 divided by 8 will give us 1 remainder 6. So 14 mod 8 is 6. Or you can use the trick we learned in the previous video. You subtract 8 from 14 and that will give us 6. 6 is less than the modulus, which is 8. So 14 mod 8 is 6. We have now completed our addition table for mode 8 on the set 0, 1, 3, 5, 7. Thank you for watching this video. Subscribe to this channel for more videos. So far, we have solved 4 questions on drawing a table for an operation in a given modulus. Sometimes, after drawing the table, you may be asked to use your table to answer some questions. In the next video, we are going to solve another question on drawing a table for an operation in a given modulus. But this time, after drawing the table, we are going to use it to answer some questions. Bye-bye. Welcome back. We are still on the topic modular arithmetic. In the previous video, we solved a question on drawing a table for an operation in a given modulus. In this video, we are going to solve another question on drawing a table for an operation in a given modulus. After drawing the table, we will use it to answer some questions. The question for this video is A. Draw an addition table for mode 5. B. Use your table to evaluate I. 2 plus 4 into brackets plus 3. II. 3 plus into brackets 4 plus 1. III. 2 plus 4 into brackets plus 3 plus 4 into another bracket. C. Find the truth set of 3 plus n is equal to 2. We are going to solve the first 2 parts of this question in this video, and we will solve the last part in the next video. Let's begin with the first part, an addition table for mode 5. The question did not define a set of values for us, so we are going to use the set of values used in mode 5 to draw the table. We have learned that in mode 5, the set of values used are 0, 1, 2, 3, 4. So we are going to use this set of values to draw our table. There are 5 values in total, so you will draw a table with 6 columns and 6 rows. We are going to draw an addition table. So the operation we are performing is addition. You write the addition sign and then you draw the circle around it. We will list the set in the first row and the first column, just as we have in the table here. We are adding these numbers in mode 5. So you have 0 plus 0, and that will give us 0. 0 in mode 5 is 0. 0 plus 1 is 1. 1 in mode 5 is 1. 0 plus 2 is 2. 2 in mode 5 is 2. 0 plus 3 is 3. 3 in mode 5 is 3. 0 plus 4 is 4. 4 in mode 5 is 4. 1 plus 0 is 1. 1 in mode 5 is 1. 1 plus 1 is 2. 2 in mode 5 is 2. 1 plus 2 is 3. 3 mode 5 is 3. 1 plus 3 is 4. 4 mode 5 is 4. 1 plus 4 is 5. 5 mode 5 is 0. 2 plus 0 is 2. 2 mode 5 is 2. 2 plus 1 is 3. 3 mode 5 is 3. 2 plus 2 is 4. 4 mode 5 is 4. 2 plus 3 is 5. 5 mode 5 is 0. 2 plus 4 is 6. 6 mode 5 is 1. 3 plus 0 is 3. 3 mode 5 is 3. 3 plus 1 is 4. 4 mode 5 is 4. 3 plus 2 is 5. 5 mode 5 is 0. 3 plus 3 is 6. 6 mode 5 is 1. 3 plus 4 is 7. 7 mode 5 is 2. 4 plus 0 is 4. 4 mod 5 is 4. 4 plus 1 is 5. 5 mod 5 is 0. 4 plus 2 is 6. 6 mod 5 is 1. 4 plus 3 is 7. 7 mod 5 is 2. And finally, 4 plus 4 is 8. 8 mod 5 is 3. So we have completed our addition table for mode 5. We have solved a lot of questions on drawing addition and multiplication tables for a given modulus. So I'm very sure that by this time you are conversant with drawing tables for an operation in a given modulus. Let's move on to the next part of our question. The B part of the question said that we should use our table to evaluate I, 2 plus 4 into brackets plus 3. When you're given a question like this, you will begin with the 1 in the bracket. So first, you will have to find 2 plus 4. So you read 2 plus 4 from the table. 2 plus 4. So you trace 2 and 4 and you will see that they will meet in this cell. This means that from the table, 2 plus 4 is equal to 1. So 2 plus 4 is now 1. So this becomes 1 plus 3. What is in the bracket is 1. So you have 1 plus 3. So you now have to read 1 plus 3 from the table. 1 plus 3. You trace 1 and 3 and you will see that they will meet in this cell. So it means that from the table, 1 plus 3 is equal to 4. Note that in an examination, you don't have to draw the arrows in the table as I've done here. I drew them to show you how to pick the values from the table. 2 plus 4 will give us 1. So you have 1 plus 3, and 1 plus 3 from the table is equal to 4. Let's move on. II. 3 plus into bracket 4 plus 1. This will give us 3 plus then what we have in the bracket. What we have in the bracket is 4 plus 1. So you read 4 plus 1 from the table. 4 plus 1. From the table, 4 plus 1 will give us 0. It means that this will become 3 plus 4 plus 1, but 4 plus 1 is now 0. So you have 3 plus 0. So you will read 3 plus 0 from the table. From the table, 3 plus 0 will be equal to 3. 3 plus 0 is equal to 3. So 3 plus into bracket 4 plus 1 is equal to 3 plus 0, which is equal to 3. Once again, I want to stress on the fact that in an examination, you don't have to draw the arrows. I'm drawing the arrows to show you how to read the values from the table. Let's move on. III. 2 plus 4 into brackets plus 3 plus 4 into brackets. You will find what is in the first bracket, then you add it to what is in the second bracket. The first bracket is 2 plus 4. So you will find 2 plus 4. We can see that from the table, 2 plus 4 will give us 1. So you have 1 plus, then we will find what is in the second bracket. The second bracket is 3 plus 4. So you will find 3 plus 4. And from the table, 3 plus 4 will give us 2. So you have 1 plus 2 because 2 plus 4 is 1 and 3 plus 4 is 2. So now you have to find 1 plus 2 from the table. We are going to find 1 plus 2 from the table and it will give us 1 plus 2. So from the table, 1 plus 2 will give us 3. This means that 2 plus 4 plus 3 plus 4 is equal to 1 plus 2, which is equal to 3. Remember that in an examination, you don't have to draw the arrows in the table. I drew them to show you how to pick the values from the table. The next part of the question says that we should find the truth set of the equation 3 plus n is equal to 2. We are going to do that in the next video. So see you in the next video and let's continue solving this question. Bye-bye. Welcome back. We started solving this question in the previous video. We solved A and B. In this video, we are going to solve the last part, that is C. Find the truth set of 3 plus n is equal to 2. So we are going to use the addition table for mode 5 we drew in the previous video to find the truth set of 3 plus n is equal to 2. The table we have here is an addition table for mode 5. We drew this table by using the set 0, 1, 2, 3, 4. The question wants us to find the truth set of 3 plus n is equal to 2. There are some values in this set that will satisfy the equation 3 plus n is equal to 2. We don't know those values. To find it, we are going to try them out one after the other to see which one of them will satisfy the equation. So we will begin with when n is equal to 0. When n is equal to 0, 3 plus n will become 3 plus 0. From the table, 3 plus 0 is equal to 3. So 3 plus 0 will give us 3. But we know that from our equation, 3 plus n is equal to 2. That means that n is not equal to 0, because if n is equal to 0, then 3 plus 0 should give us 2. But here, 3 plus 0 is giving us 3. That means that the number we are looking for is not 0. Let's move on to the next number in the set, which is 1. So when n is equal to 1. When n is equal to 1, 3 plus n will become 3 plus 1. From the table, 3 plus 1 will give us 4. We know that from our equation, 3 plus n is equal to 2. But when n is equal to 1, 3 plus 1 will give us 4. That means that n is not 1, because if n is 1, 3 plus 1 should give us 2. From the table, 3 plus 1 is equal to 4, not 2. So n is not equal to 2. So we are going to try out the next number in the set, which is 2. When n is equal to 2, 3 plus n becomes 3 plus 2. From the table, 3 plus 2 will give us 0. But we know that from our equation, 3 plus n is giving us 2. So if n is equal to 2, then 3 plus 2 should give us 2. But we have seen from the table that 3 plus 2 is giving us 0. That means that n is not equal to 2. So we are going to try out the next number, which is 3. When n is equal to 3, 3 plus n will become 3 plus 3. From the table, 3 plus 3 will give us 1. But we know that from our equation, 3 plus n should give us 2. Here, when n is equal to 3, 3 plus n will give us 1. 2 is not equal to 1. This means that n is not equal to 3. So we will try out the last number, which is 4, when n is equal to 4. When n is equal to 4, 3 plus n will be equal to 3 plus 4. From the table, 3 plus 4 is giving us 2. We know that from our equation, 3 plus n should give us 2. Now we can see that when n is equal to 4, 3 plus 4 will give us 2. That means that n is equal to 4. So the number in the set that will satisfy the equation 3 plus n is equal to 2 is 4. So n is equal to 4. The question said we should find the truth set of this equation. In the videos on linear equations and linear inequalities, we learned how to write the truth set of an equation. The truth set of this equation is n is such that n is equal to 4. Remember that you write it in a curly bracket. So the truth set is n is such that n is equal to 4. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on drawing a table for an operation in a given modulus. After drawing the table, we will use it to answer some questions. Bye-bye. Welcome back. We are on the topic modular arithmetic. In the previous video, We solved a question on drawing a table for an operation in a given modulus. In this video, we are going to solve another question. The question for this video is: draw an addition and multiplication table for mode 15 for the set 3, 6, 9, 12. From your table, evaluate I. 3 times 6 into bracket plus 3 times 9 into another bracket. II. Find the truth set of n times into bracket n plus 3 is equal to 3. We will draw the addition and multiplication tables in this video. In the next video, we are going to use our tables to solve the remaining part of the question. Let's begin by drawing the addition table for mode 15 for the set 3, 6, 9, 12. As you can see, we were given a set of values in the question, so we are going to use that set of values to draw the table. There are 4 values in the set, so we are going to draw a table with 5 columns and 5 rows. In the first cell, we will indicate the sign of the operation we are going to perform. We are drawing an addition table, so you write the addition sign and you draw a circle around it. You then list the set of numbers in the first row and the first column. We have 3, 6, 9, 12 and 3, 6, 9, 12. We are adding the numbers in mode 15. The first one is 3 plus 3. 3 plus 3 is 6. 6 mode 15 is 6. 3 plus 6 is 9. 9 mode 15 is 9. 3 plus 9 is 12. 12 mode 15 is 12. 3 plus 12 is 15. 15 mode 15 is 0. Let's move on to the next rule. 6 plus 3 is 9. 9 mode 15 is 9. 6 plus 6 is 12. 12 mode 15 is 12. 6 plus 9 is 15. 15 mode 15 is 0. 6 plus 12 is 18. 18 mode 15 is 3. So 18 is greater than the modulus, which is 15. So if you want to find 18 mode 15, you divide 18 by 15, and that will give us 1 remainder 3. Or you can use the trick that we've learned. You subtract 15 from 18 and you get 3. So 18 mode 15 is 3. Let's move on to the next rule. 9 plus 3 is 12. 12 mode 15 is 12. 9 plus 6 is 15. 15 mode 15 is 0. 9 plus 9 is 18. 18 mode 15 is 3. 9 plus 12 is 21. 21 mode 15 is 6, because 21 divided by 15 will give us 1 remainder 6. Or if you want to use the trick that we have learned, you subtract 15 from 21 and you get 6. So 21 mode 15 is 6. 12 plus 3 is 15. 15 mode 15 is 0. 12 plus 6 is 18. 18 mode 15 is 3. 12 plus 9 is 21. 21 mode 15 is 6. And finally, 12 plus 12 is 24. 24 mode 15 is 9, because 24 divided by 15 will give us 1 remainder 9, or 24 minus 15 will give us 9, which is less than the modulus. So 24 mode 15 is 9. We have now completed the addition table for mode 15 on the set 3, 6, 9, 12. Let's move on to the multiplication table. 3 times 3 will give us 9. 9 mode 15 is 9. 3 times 6 is 18. 18 mode 15 is 3. 3 times 9 is 27. 27 mode 15 is 12. 3 times 12 is 36. 36 mode 15 is 6. 6 times 3 is 18. 18 mode 15 is 3. 6 times 6 is 36. 36 mode 15 is 6. 6 times 9 is 54. 54 mod 15 is 9. 6 times 12 will give us 72. 72 mod 15 is 12. Let's move on to the next rule. 9 times 3 will give us 27. 27 mod 15 is 12. 9 times 6 will give us 54. 54 mod 15 is 9. 9 times 9 will give us 81. 81 mod 15 is 6. 9 times 12 will give us 108. 108 mod 15 is 3. Let's move on to the last rule. 12 times 3 will give us 36. 36 mod 15 is 6. 12 times 6 will give us 72. 72 mod 15 is 12. 12 times 9 will give us 108. 108 mod 15 is 3. And finally, 12 times 12 will give us 144. 144 mod 15 is 9. If you want to use the trick to find 144 mod 15 in the calculator, subtract 15 from 144 and you have 129. You subtract 15 from 129, you have 114. You subtract 15 from 114, you have 99. You subtract 15 from it, you have 84. You subtract 15 from 84, you have 69. You subtract 15 from 69, you have 54. Then you subtract 15 from it again, you have 39. You subtract 15 from it again, you have 24. Then you subtract 15 from it again, and you have 9. So you keep on subtracting the modulus from the number until you get a value that is less than the modulus. We have completed the multiplication table for mod 15 on the set 3, 6, 9, 12. So now we have both the addition and multiplication tables for mod 15 on the set 3, 6, 9, 12. The next part of the question says that we should use our tables to evaluate I. 3 times 6 into brackets plus into brackets 3 times 9. I. Find the truth set of n times into brackets n plus 3 is equal to 3. We are going to do this in the next video. So see you in the next video and let's continue solving the question. Bye-bye. Welcome back. We started solving this question in the previous video. We drew the addition and multiplication table for mod 15 on the set 3, 6, 9, 12. In this video, we are going to use the tables that we drew in the previous video to evaluate I, 3 times 6 plus 3 times 9, and also find the truth set of n times into brackets n plus 3 is equal to 3. So let's begin. The first one says that we should use our table to evaluate 3 times 6 plus into bracket 3 times 9. So you have to find 3 times 6 from the table. From the table, 3 times 6 will give us 3. So the content of the first bracket, that is 3 times 6, will give us 3. So you have 3 plus, you have to find 3 times 9 from the table. From the table, 3 times 9 will give us 12. So 3 times 6 will give us 3, and 3 times 9 will give us 12. So you have 3 plus 12. From the table, 3 plus 12 is equal to 0. So 3 plus 12 will give us 0. So 3 times 6, we can find it from the multiplication table. 3 times 9, we can find it from the multiplication table. Then we will find 3 plus 12 from the addition table. From the addition table, 3 plus 12 will give us 0. The next part of the question says that we should use our tables to find the truth set of n times into bracket n plus 3 is equal to 3. We drew addition and multiplication tables for mod 15 on the set 3, 6, 9, 12. There are some values in the set 3, 6, 9, 12 that will satisfy this equation. To find those values, we are going to try them out one after the other. We will begin with the first one, which is 3. So when n is equal to 3, when n is equal to 3, n times into brackets n plus 3 will become 3 times into brackets 3 plus 3 because n is now 3. You have to find what is in the bracket, 3 plus 3. So you go to the addition table. From the addition table, 3 plus 3 is 6. So this will become 3 times 3 plus 3 is now 6. So 3 times 6. To find 3 times 6, we go to the multiplication table. From the multiplication table, 3 times 6 will give us 3. So 3 times 6 is 3. We can see that n is equal to 3 satisfies this equation because when we substitute n is equal to 3 into the expression n times into bracket n plus 3, we are having a final answer of 3. So one of the numbers in this set that will satisfy the equation is 3. Let's try out the other numbers and see. The next one is when n is equal to 6. When n is equal to 6, n times into bracket n plus 3 will become 6 times into bracket 6 plus 3. We are going to find 6 plus 3 from the addition table. From the addition table, 6 plus 3 will give us 9. So you have 6 times 9. You will find 6 times 9 from the multiplication table. From the multiplication table, 6 times 9 will give us 9. But we know that from our equation, n times into bracket n plus 3 should give us 3. But here, when n is equal to 6, 6 times into bracket 6 plus 3 will give us 9. That means that 6 will not satisfy the equation, so n is not equal to 6. Let's try out the next number, which is 9. When n is equal to 9, the expression n times into brackets 9 plus 3 will become 9 times into brackets 9 plus 3. 9 plus 3 from the addition table will be 9 plus 3 is 12. So you have 9 times 9 plus 3, which is 12. Let's find 9 times 12 from the multiplication table. From the multiplication table, 9 times 12 is 3. So we can see that n is equal to 9 will also satisfy the equation because when n is equal to 9, the expression 9 times into brackets 9 plus 3 will give us 3. So one of the values in this set that will satisfy the equation is 9. So we have seen that 3 will satisfy the equation and 9 will also satisfy the equation. Let's try out the last number, which is 12. When n is equal to 12. When n is equal to 12, the expression n times into bracket n plus 3 will become 12 times into bracket 12 plus 3. From the addition table, 12 plus 3 is 0. So you have 12 times 0. We don't have 0 in the set of numbers we used to draw the table, so we can't find 12 times 0 from the table. What this means is that n is equal to 12 will not satisfy the equation, so n is not equal to 12. From our calculations, we have seen that the two numbers that satisfies the equation n times into bracket n plus 3 is equal to 3 are 3 and 9. The question said we should find the truth set of this equation. So the truth set is n is such that n is equal to 3 and 9. Remember that when you are writing your truth set, you will put it in a curly bracket. So the truth set of the equation is n is such that n is equal to 3 and 9. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to learn how to solve questions involving binary operation and modular arithmetic. Bye-bye. Welcome back. We are still on the topic modular arithmetic. In the previous video, we drew a table for an operation in a given modulus, and we used our table to solve some questions. In this video, we are going to learn how to solve questions involving binary operation and modular arithmetic. Binary operation and modular arithmetic. In the second and third videos on the topic real number system, we considered binary operation into details. In those videos, we learned that the four basic binary operators are addition, subtraction, division, and multiplication. These binary operators combine numbers to produce a result. So for example, 2 plus 3 will give us 5. 5 minus 4 will give us 1. 2 times 2 will give us 4. 2 divided by 4 will give us half. So these binary operators combine numbers to produce a result. We also learned in those videos that there are other binary operators apart from these basic ones. So apart from addition, subtraction, division, and multiplication, there are other binary operators, and they can also combine numbers to produce a result. So for example, let's consider this operator star, which is defined as A star B is equal to A plus B minus 2. We can use the definition of this operator star to evaluate the following: I 3 star 4, II 2 star 1, III 5 star 4. In the videos on binary operation and the real number system, we learned how to evaluate these by using the definition. I'm going to go over it quickly in this video. So the definition of star is A star B is equal to A plus B minus 2. We are going to use this definition to evaluate 3 star 4. From the definition, we can see that A star B is equal to A plus B minus 2. So it means that the first number, which is A, plus the second number, which is B, then minus 2. We want to evaluate 3 star 4. So 3 star 4 is going to be the first number, which is 3, plus the second number, which is 4, minus 2. 3 plus 4 minus 2 will give us 5. The next one is 2 star 1. So 2 star 1 will be equal to the first number, which is 2, plus the second number, which is 1, minus 2. 2 plus 1 minus 2 will give us 1. The next one is 5 star 4. From the definition, 5 star 4 will be equal to the first number, so 5, plus the second number, 4, then minus 2. 5 plus 4 minus 2 will give us 7. So you can see that using the definition A star B is equal to A plus B minus 2, we have been able to evaluate 3 star 4, 2 star 1, and 5 star 4. We learnt this in the video on binary operation and the real number system. Now let's consider something. What if this operation star, which is defined as A star B is equal to A plus B minus 2, is defined in a certain modulus? So for example, consider the operation star, which is defined as A star B is equal to A plus B minus 2 in mode 4. So you can see that this time the definition of star is given to us in mode 4. We can use this definition to evaluate 3 star 4, 2 star 1, and 5 star 4. Let's see how to do that. So now the definition is A star B is equal to A plus B minus 2 in mode 4. To find 3 star 4, we will first use the binary operation to evaluate 3 star 4. We have seen how to do it. We are going to have 3, which is the first number, plus 4, which is the second number, minus 2. 3 plus 4 minus 2 will give us 5. But this time, the definition of the binary operation was given to us in mode 4. So if we have been able to evaluate 3 star 4 and we are having 5, we will have to find 5 in mode 4. 5 in mode 4, which is written as 5 mode 4, is equal to 1. So 3 star 4 in mode 4 will give us 1, because 3 star 4 is 5 and 5 in mode 4 is 1. Let's try out the next question. 2 star 1. We will first use the definition of the binary operation to find 2 star 1. We have seen how to do that. We are going to have 2, which is the first number, plus 1, which is the second number, minus 2. 2 plus 1 minus 2 will give us 1. The definition of the binary operation was given to us in mode 4. So if 2 star 1 is 1, we will have to find 1 in mode 4. 1 in mode 4, which is written as 1 mode 4, is equal to 1. So using the definition, we have been able to find 2 star 1 in mode 4. 2 star 1 is 1 and 1 mode 4 is 1. Let's look at the last one, 5 star 4. We are going to use the definition to find 5 star 4. So you will have 5, which is the first number, plus 4, which is the second number, because 5 star 4 means that A is now 5 and B is 4. So you have 5 plus 4 minus 2. 5 plus 4 minus 2 will give us 7. But the definition of the binary operation was given to us in mode 4. We have found out that 5 star 4 is 7. So you have to find 7 in mode 4. 7 in mode 4, which is written as 7 mode 4, is equal to 3. So we can see that when a binary operation is defined in a certain modulus, you will first use the definition of the binary operation to evaluate the expression. So for example, we use the definition A star B is equal to A plus B minus 2 to evaluate 3 star 4, and you have 5. After that, you find the value of the expression in the modulus. So after we have evaluated 3 star 4 and we are having 5, you find the value of 5 in mode 4. 5 in mode 4 will give us 1. We used the definition to evaluate 2 star 1 and we got 1. After that, you find the value of 1 in mode 4 and that will give us 1. We used the definition to evaluate 5 star 4 and we got 7. After that, you find the value of 7 in mode 4. 7 mode 4 will give us 3. Thank you for watching this video. Subscribe to this channel for more videos. In this video, we have learned how to solve questions involving binary operation and modular arithmetic. In the next video, we are going to apply what you have studied in this video to solve a question on drawing tables for a binary operation in a given modulus. Bye-bye. Welcome back. We are still on the topic modular arithmetic. In the previous video, we learned how to solve questions involving modular arithmetic and binary operation. In this video, we are going to apply what we studied in the previous video to solve a question on drawing a table for a given binary operation in a given modulus. The question for this video is, the operation star is defined by x star y is equal to xy plus 2 in mode 7. I. Draw a table for star on the set 1, 3, 5, 6. II. From the table, find the truth set of 3 star n is equal to 5. So in this question, the operation star has been defined for us as x star y is equal to xy plus 2 in mode 7. We are being asked to draw a table for star on the set 1, 3, 5, 6. And after that, we will use our table to find the truth set of the equation 3 star n is equal to 5. We will solve the first part in this video. And in the next video, we will use the table that we will draw to find the truth set of 3 star n is equal to 5. So let's begin by drawing the table for star on the set 1, 3, 5, 6. We have been given a set of numbers in the question. The set is 1, 3, 5, 6. So we are going to use this set to draw the table. We have 4 values in the set. So we are going to draw a table with 5 columns and 5 rows. In the first cell, you indicate the operation you are going to perform. The operation is star, so you indicate star in the first cell. Then you list the members in the first row and the first column. We have 1, 3, 5, 6 and 1, 3, 5, 6. The definition of star is x star y is equal to xy plus 2. So x star y is equal to x times y plus 2. Let's fill the table. The first one is 1 star 1. So it means that x is 1 and y is 1. So 1 star 1 will be equal to xy, which is x times y. So 1 times 1 plus 2. 1 times 1 is 1. So you have 1 plus 2. And 1 plus 2 will give us 3. But remember that the operation star is defined in mode 7. So after we have found 1 star 1, you have to find the value of 1 star 1 in mode 7. 1 star 1 is 3. So you have to find 3 in mode 7. 3 mode 7 or 3 in mode 7 is equal to 3. That means that 1 star 1 in mode 7 is 3. The next one is 1 star 3. 1 star 3 will be equal to 1 times 3 plus 2 because x is 1 and y is 3. So you have 1 times 3 plus 2. 1 times 3 is 3. 3 plus 2 will give us 5. So we have now found 1 star 3. But the operation is defined in mode 7. So we have to find the value of 1 star 3 in mode 7. 1 star 3 is 5. 5 in mode 7 will give us 5. Let's move on. The next one is 1 star 5. 1 star 5 will be equal to 1 times 5 plus 2. 1 times 5 is 5. So you have 5 plus 2. And 5 plus 2 will give us 7. You will find 7 in mode 7 since the operation is defined in mode 7. 7 mode 7 is 0. So 1 star 5 mode 7 is 0. The next one is 1 star 6. 1 star 6 is equal to 1 times 6 plus 2. 1 times 6 is 6. 6 plus 2 is 8. You will find 8 in mode 7. 8 mode 7 is 1. Let's move on to the next row. 3 star 1. 3 star 1 will be equal to 3 times 1 plus 2 because x is 3 and y is 1. So 3 times 1 plus 2. 3 times 1 is 3. You have 3 plus 2 and 3 plus 2 give us 5. Then you find 5 in mode 7. 5 mode 7 will give us 5. The next one is 3 star 3. 3 star 3 will give us 3 times 3 plus 2. 3 times 3 will give us 9. 9 plus 2 will give us 11. You find 11 in mode 7. 11 mode 7 will give us 4. The next one is 3 star 5. 3 star 5 will give us 3 times 5 plus 2. 3 times 5 is 15. 15 plus 2 is 17. You find 17 mode 7. And 17 mode 7 is equal to 3. The next one is 3 star 6. 3 star 6 will be equal to 3 times 6 plus 2. 3 times 6 is 18. 18 plus 2 will give us 20. You find 20 mode 7. And 20 mode 7 is equal to 6. Let's move on to the next row. 5 star 1. 5 star 1 will be equal to 5 times 1 plus 2 because x is 5 and y is 1. So you have 5 times 1 plus 2. 5 times 1 is 5. 5 plus 2 will give us 7. 7 mode 7 is 0. The next one is 5 star 3. 5 star 3 is equal to 5 times 3 plus 2. 5 times 3 is 15. 15 plus 2 will give us 17. You find 17 mode 7. And 17 mode 7 is equal to 3. The next one is 5 star 5. 5 star 5 is equal to 5 times 5 plus 2. 5 times 5 will give us 25. 25 plus 2 will give us 27. You find 27 in mode 7, and 27 mode 7 is equal to 6. The next one is 5 star 6. 5 star 6 is equal to 5 times 6 plus 2. 5 times 6 is 30. 30 plus 2 is 32. You find 32 mode 7, and 32 mode 7 is equal to 4. Let's move on to the last rule. 6 star 1. 6 star 1 is equal to 6 times 1 plus 2. 6 times 1 is 6. 6 plus 2 is 8. You find 8 in mode 7. 8 mode 7 is 1. 6 star 3 is equal to 6 times 3 plus 2. 6 times 3 is 18. 18 plus 2 is 20. You find 20 in mode 7. 20 mode 7 is equal to 6. The next one is 6 star 5. 6 star 5 is equal to 6 times 5 plus 2. 6 times 5 is 30. 30 plus 2 is 32. 32 mode 7 is 4. And the last one is 6 star 6. 6 star 6 is equal to 6 times 6 plus 2. 6 times 6 is 36. 36 plus 2 is 38. And 38 mode 7 is equal to 3. We have now completed the table for star, which is defined as x star y is equal to xy plus 2 in mode 7 on the set 1, 3, 5, 6. The next part of the question says that we should use our table to find the truth set of the equation 3 star n is equal to 5. We are going to do that in the next video. So see you in the next video, and let's continue solving the question. Bye-bye. Welcome back. We started solving this question in the previous video, and we drew the table for star on the set 1, 3, 5, 6. In this video, we are going to use the table we drew in the previous video to find the truth set of the equation 3 star n is equal to 5. So we are going to use this table to find the truth set of 3 star n is equal to 5. We drew the table for the operation star on the set 1, 3, 5, 6. There are some values in this set that will satisfy the equation 3 star n is equal to 5. To find those values, we are going to try them out one after the other. We will begin with the first one, which is 1. Remember that the equation is 3 star n is equal to 5. When n is equal to 1, the expression 3 star n will be equal to 3 star 1. From the table, 3 star 1 will give us 5. So from the table, we can see that 3 star 1 is equal to 5. That means that when n is equal to 1, 3 star 1 will be equal to 5. So 1 will satisfy this equation. So n is equal to 1. Let's try out the other numbers and see. The next one is 3. When n is equal to 3. When n is equal to 3, the expression 3 star n will be equal to 3 star 3. From the table, 3 star 3 is equal to 4. But we know that from the equation, 3 star n should give us 5. When n is equal to 3, 3 star 3 is giving us 4. That means that n is equal to 3 will not satisfy this equation. So n is not equal to 3. Let's try the next one, 5. When n is equal to 5. When n is equal to 5, the expression 3 star n will become 3 star 5. From the table, 3 star 5 will give us 3. So 3 star 5 is 3. But from our equation, we know that 3 star n should give us 5. When n is equal to 5, 3 star 5 is giving us 3. That means that n is equal to 5 will not satisfy the equation. So n is not equal to 5. Let's try the last one and see if it will satisfy the equation. The last one is 6. when n is equal to 6. When n is equal to 6, 3 star n will be equal to 3 star 6. From the table, 3 star 6 is 6. So 3 star 6 is equal to 6. But from our equation, 3 star n should give us 5. When n is equal to 6, 3 star 6 is giving us 6. 6 is not equal to 5. That means that n is equal to 6 will not satisfy the equation. So n is not equal to 6. So the only number in the set that satisfied the equation was 1. The question said we should find the truth set. So the truth set of the equation 3 star n is equal to 5 is equal to n is such that n is equal to 1. Remember that it is a truth set, so you are going to write your answer in a curly bracket. So the truth set of this equation is n is such that n is equal to 1. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on drawing a table for a binary operation in a given modulus. Bye-bye. Welcome back. We are still on the topic modular arithmetic. In the previous video, we solved a question on drawing a table for a binary operation in a given modulus. In this video, we are going to solve another question. The question for this video is, draw the table for the operation star and delta, which are defined in mode 5 by a star b is equal to a plus b plus 3ab, and a delta b is equal to ab plus 2, where a and b belongs to x and x is equal to 0, 1, 2, 3, 4. Use your tables to evaluate I. 2 delta into bracket 3 star 4 II. 2 delta 3 star 2 delta 4 III. 2 delta 4 star 3 delta 3. So we are being asked to draw two tables. We will draw one for star, which is defined as a star b is equal to a plus b plus 3ab. And then we will draw another one for delta, which is defined as a delta b is equal to ab plus 2, where a and b belongs to the set S, and the set S is given as 0, 1, 2, 3, 4. Note that the operations star and delta are defined in mode 5. So we are going to use the definition for star and delta to draw a table for the set 0, 1, 2, 3, 4 in mode 5. After that, we will use the tables to evaluate the following. Let's begin by drawing the table for star. The definition for star is a star b is equal to a plus b plus 3ab in mode 5 on the set S, which is 0, 1, 2, 3, 4. So we have been given a set of values in the question. We are going to use that set of values to draw the table. Remember that we are drawing a table for star in mode 5. We have 5 values in the set, so we will draw a table with 6 columns and 6 rows. In the first cell, you indicate the operation you are going to perform. The operation is star, so you indicate star in the first cell. Then you list the set of numbers in the first row and the first column. The definition of star is a star b is equal to a plus b plus 3ab. That means that the first number plus the second number plus 3 times the first number times the second number. Let's fill the table. The first one is 0 star 0. 0 star 0 will be equal to 0 plus 0 plus 3 times 0 times 0, because 3ab is the same as 3 times a times b. So 0 star 0 will be equal to 0 plus 0 plus 3 times 0 times 0. And this will give us 0 plus 0. 0 plus 0 is 0. We will find 0 in mode 5 because star is defined in mode 5. 0 in mode 5 is 0. Let's move on to the next one. 0 star 1. 0 star 1 will be equal to 0 plus 1 plus 3 times 0 times 1. 0 plus 1 is 1. 3 times 0 times 1 is 0. 1 plus 0 is 1. And 1 in mode 5 is 1. The next one is 0 star 2. 0 star 2 is equal to 0 plus 2 plus 3 times 0 times 2. 0 plus 2 is 2. 3 times 0 times 2 will give us 0. 2 plus 0 is 2. 2 in mode 5 is 2. The next one is 0 star 3. 0 star 3 is equal to 0 plus 3 plus 3 times 0 times 3. 3 plus 0 will give us 3. 3 times 0 times 3 is 0. 3 plus 0 will give us 3. 3 in mode 5 is 3. The next one is 0 star 4. 0 star 4 will be equal to 0 plus 4 plus 3 times 0 times 4. 0 plus 4 is 4. 3 times 0 times 4 will give us 0. 4 plus 0 is 4. And 4 in mode 5 is 4. Let's move on to the next rule. 1 star 0. 1 star 0 will be equal to 1 plus 0 plus 3 times 1 times 0. And this will be equal to 1 plus 0. 1 plus 0 is 1. 1 in mode 5 is 1. The next one is 1 star 1. 1 star 1 is equal to 1 plus 1 plus 3 times 1 times 1. And this will give us 2 plus 3. 2 plus 3 is 5. 5 mode 5 is 0. The next one is 1 star 2. 1 star 2 is equal to 1 plus 2 plus 3 times 1 times 2. This will give us 3 plus 6. 3 plus 6 is 9. And 9 in mode 5 is 4. The next one is 1 star 3. 1 star 3 is equal to 1 plus 3 plus 3 times 1 times 3. 1 plus 3 is 4. 3 times 1 times 3 is 9. 4 plus 9 will give us 13. 13 mode 5 is 3. 1 star 4. 1 star 4 is equal to 1 plus 4 plus 3 times 1 times 4. 1 plus 4 is 5. 3 times 1 times 4 is 12. 5 plus 12 will give us 17. 17 mode 5 is 2. The next one is 2 star 0. 2 star 0 is equal to 2 plus 0 plus 3 times 2 times 0. This will give us 2 plus 0, and 2 plus 0 is equal to 2. 2 mode 5 is 2. The next one is 2 star 1. 2 star 1 is equal to 2 plus 1 plus 3 times 2 times 1. And this is equal to 3 plus 6. 3 plus 6 is 9. 9 mode 5 is 4. 2 star 2. 2 star 2 is equal to 2 plus 2 plus 3 times 2 times 2. This will be equal to 4 plus 12. 4 plus 12 is 16. 16 mode 5 is 1. The next one is 2 star 3. 2 star 3 is equal to 2 plus 3 plus 3 times 2 times 3. And this is equal to 5 plus 18. 5 plus 18 is 23. 23 mode 5 is 3. The next one is 2 star 4. 2 star 4 is equal to 2 plus 4 plus 3 times 2 times 4. 2 plus 4 is 6. 3 times 2 times 4 is 24. 6 plus 24 is 30. 30 mode 5 is 0. Let's move on to the next rule. 3 star 0. 3 star 0 will give us 3 plus 0 plus 3 times 3 times 0. And this will give us 3 plus 0. 3 plus 0 is 3. 3 in mode 5 is 3. 3 star 1. 3 star 1 is equal to 3 plus 1 plus 3 times 1. And it's equal to 4 plus 9. 4 plus 9 will give us 13. 13 mode 5 is 3. The next one is 3 star 2. 3 star 2 is equal to 3 plus 2 plus 3 times 2. And it will give us 5 plus 18. 5 plus 18 is 23. 23 mode 5 is 3. The next one is 3 star 3. 3 star 3 will give us 3 plus 3 plus 3 times 3 times 3. 3 plus 3 will give us 6. 3 times 3 times 3 will give us 27. 6 plus 27 is 33. 33 mode 5 is 3. The next one is 3 star 4. 3 star 4 is equal to 3 plus 4 plus 3 times 4. And we will have 7 plus 36. 7 plus 36 is 43. 43 mode 5 is 3. We move on to the last rule. 4 star 0. 4 star 0 is equal to 4 plus 0 plus 3 times 4 times 0. And you have 4 plus 0. 4 plus 0 is 4. 4 in mode 5 is 4. 4 star 1. 4 star 1 is equal to 4 plus 1 plus 3 times 4 times 1. 4 plus 1 is 5. 3 times 4 times 1 is 12. 5 plus 12 will give us 17. And 17 in mode 5 or 17 mode 5 is 2. The next one is 4 star 2. 4 star 2 is equal to 4 plus 2 plus 3 times 4 times 2. 4 plus 2 is 6. 3 times 4 times 2 is 24. 6 plus 24 is 30. 30 mode 5 is 0. The next one is 4 star 3. 4 star 3 is equal to 4 plus 3 plus 3 times 4 times 3. And we will have 7 plus 36. 7 plus 36 is 43. 43 mode 5 is 3. And the last one is 4 star 4. 4 star 4 is equal to 4 plus 4 plus 3 times 4 times 4. 4 plus 4 is 8. 3 times 4 times 4 will give us 48. 8 plus 48 is 56. And 56 mode 5 is 1. So we have now completed the table for star, which is defined as A star B is equal to A plus B plus 3AB in mode 5 on the set 0, 1, 2, 3, 4. The question said that we should draw a table for delta, which is defined as A delta B is equal to AB plus 2 in mode 5 on the set 0, 1, 2, 3, 4. We are going to do that in the next video. So see you in the next video and let's continue with the solution. Bye-bye. Welcome back. We started solving this question in the previous video. We drew the table for star, which is defined as A star B is equal to A plus B plus 3AB in mode 5 on the set 0, 1, 2, 3, 4. In this video, we are going to draw the table for the operation delta, which is defined as A delta B is equal to AB plus 2 in mode 5 on the set 0, 1, 2, 3, 4. So we are going to draw a table for delta, which is defined as A delta B is equal to AB plus 2 in mode 5 on the set 0, 1, 2, 3, 4. There are 5 values in the set. So we are going to draw a table with 6 columns and 6 rows. In the first cell, you indicate the sign of the operation we are going to perform. The operation is delta, so you indicate delta in the first cell. Then You will list the set of values in the first row in the first column. We have 0, 1, 2, 3, 4 and 0, 1, 2, 3, 4. The definition of delta is A delta B is equal to AB plus 2 in mode 5. Let's fill the table. The first one is 0 delta 0. A delta B is equal to AB plus 2. That is, A delta B is equal to A times B plus 2. So 0 delta 0 will be equal to 0 times 0 plus 2. So the first number times the second number plus 2. 0 delta 0 is equal to 0 times 0 plus 2. 0 times 0 is 0. 0 plus 2 is 2. And 2 in mode 5 is 2. The next one is 0 delta 1. 0 delta 1 is equal to 0 times 1 plus 2. This will give us 0 plus 2, and 0 plus 2 will give us 2. 2 mode 5 is 2. The next one is 0 delta 2. 0 delta 2 is equal to 0 times 2 plus 2. This will give us 0 plus 2. 0 plus 2 is 2. 2 mode 5 is 2. The next one is 0 delta 3. 0 delta 3 is equal to 0 times 3 plus 2. 0 times 3 is 0. 0 plus 2 is 2. 2 mode 5 is 2. The next one is 0 delta 4. 0 delta 4 is equal to 0 times 4 plus 2. 0 plus 2 will give us 2. 2 mode 5 is 2. Let's move on to the next row. You have 1 delta 0. 1 delta 0 is equal to 1 times 0 plus 2. This will give us 0 plus 2, and 0 plus 2 is 2. 2 mode 5 is 2. The next one is 1 delta 1. 1 delta 1 is equal to 1 times 1 plus 2. This will give us 1 plus 2. 1 plus 2 is 3. 3 mode 5 is 3. The next one is 1 delta 2. 1 delta 2 is equal to 1 times 2 plus 2. This will give us 2 plus 2. 2 plus 2 is 4. And 4 mode 5 is 4. The next one is 1 delta 3. 1 delta 3 is equal to 1 times 3 plus 2. This will give us 3 plus 2. 3 plus 2 is 5. 5 mode 5 is 0. The next one is 1 delta 4. 1 delta 4 is equal to 1 times 4 plus 2. This will give us 4 plus 2. 4 plus 2 is 6. 6 mode 5 is 1. Let's move on to the next rule. 2 delta 0. 2 delta 0 is equal to 2 times 0 plus 2. 2 times 0 is 0. So you have 0 plus 2, and 0 plus 2 will give us 2. 2 mode 5 is 2. The next one is 2 delta 1. 2 delta 1 is equal to 2 times 1 plus 2. 2 times 1 is 2. 2 plus 2 will give us 4. 4 mode 5 is 4. The next one is 2 delta 2. 2 delta 2 will be equal to 2 times 2 plus 2. 2 times 2 is 4. So we have 4 plus 2. 4 plus 2 is 6. 6 mode 5 is 1. The next one is 2 delta 3. 2 delta 3 is equal to 2 times 3 plus 2. 2 times 3 is 6. 6 plus 2 is 8. 8 mode 5 is 3. The next one is 2 delta 4. 2 delta 4 is equal to 2 times 4 plus 2. 2 times 4 is 8. 8 plus 2 is 10. 10 mode 5 is 0. Let's move on to the next rule. 3 delta 0. 3 delta 0 is equal to 3 times 0 plus 2. 3 times 0 is 0. 0 plus 2 is 2. 2 mode 5 is 2. The next one is 3 delta 1. 3 delta 1 is equal to 3 times 1 plus 2. 3 times 1 is 3. 3 plus 2 is 5. 5 mode 5 is 0. The next one is 3 delta 2. 3 delta 2 is equal to 3 times 2 plus 2. 3 times 2 is 6. 6 plus 2 is 8. 8 mode 5 is 3. The next one is 3 delta 3. 3 delta 3 is equal to 3 times 3 plus 2. 3 times 3 is 9. 9 plus 2 is 11. 11 mod 5 is 1. The next one is 3 delta 4. 3 delta 4 is equal to 3 times 4 plus 2. 3 times 4 is 12. 12 plus 2 is 14. 14 mod 5 is 4. Let's move on to the last rule. 4 delta 0. 4 delta 0 is 4 times 0 plus 2. 4 times 0 is 0. 0 plus 2 is 2. And 2 mod 5 is 2. The next one is 4 delta 1. 4 delta 1 is equal to 4 times 1 plus 2. 4 times 1 is 4. 4 plus 2 is 6. And 6 in mod 5 is 1. The next one is 4 delta 2. 4 delta 2 is equal to 4 times 2 plus 2. 4 times 2 is 8. 8 plus 2 is 10. 10 in mod 5 is 0. The next one is 4 delta 3. 4 delta 3 is equal to 4 times 3 plus 2. 4 times 3 is 12. And 12 plus 2 is 14. 14 mod 5 is 4. The last one is 4 delta 4. 4 delta 4 is equal to 4 times 4 plus 2. 4 times 4 is 16. And 16 plus 2 is 18. 18 mod 5 is equal to 3. We have completed the table for delta, which is defined as A delta B is equal to AB plus 2 in mode 5 on the set 0, 1, 2, 3, 4. In the previous video, we completed the table for star, which is defined as A star B is equal to A plus B plus 3AB in mode 5 on the set 0, 1, 2, 3, 4. In this video, we have completed the table for delta, which is defined as A delta B is equal to AB plus 2 in mode 5 on the set 0, 1, 2, 3, 4. The question said that we should use our tables for star and delta to evaluate I. 2 delta into bracket 3 star 4, I. 2 delta 3 into bracket star 2 delta 4 into brackets, I. 2 delta 1 into brackets, star 3 star 3 into brackets. We will do this in the next video. So see you in the next video and let's continue with the solution. Bye-bye. Welcome back. We are still on the solution to this question. We have completed the tables for star and delta in the previous videos. In this video, we are going to use the tables to evaluate the following. The first one is 2 delta into bracket 3 star 4. The second one is 2 delta 3 star 2 delta 4. And the last one is 2 delta 1 star 3 star 3. Let's begin with the first one. 2 delta into bracket 3 star 4. So you will first have to find what is in the bracket. We will have 2 delta, then we find what is in the bracket, which is 3 star 4. 3 star 4 from the table will give us 3. So you have 2 delta 3. Then you read 2 delta 3 from the delta table. You have 2 delta 3, which is 3. So from the table, 2 delta into bracket 3 star 4 is equal to 2 delta 3, which is equal to 3. The next one is 2 delta 3 star 2 delta 4. So you read what is in the first bracket, 2 delta 3. From the table, 2 delta 3 will give us 3. So we have 2 delta 3, then star 2 delta 4. 2 delta 4 will give us 0. So 2 delta 3 will give us 3 and 2 delta 4 will give us 0. We will now have to find 3 star 0. 3 star 0 from the table will give us 3. So 2 delta 3 star 2 delta 4 is equal to 3 star 0, which is equal to 3. The last one is 2 delta 1 star 3 star 3. So you begin with the first bracket, 2 delta 1. 2 delta 1 will give us 4. So we have 4 star, you have to find the second, what is in the second bracket, which is 3 star 3. 3 star 3 will give us 3. So now we have 4 star 3. 4 star 3 from the table will give us 3. So 2 delta 1 is 4, 3 star 3 is 3, and 4 star 3 will give us 3. Thank you for watching this video. Subscribe to this channel for more videos. This is the end of the videos on modular arithmetic. Pick more examples on your own and try your hands on them. If you face any difficulty solving the questions, share it on my social media handles and I'll respond to it. Bye-bye.